So, Sunita, we're here to talk about OpenACC and what's new at ISC 17.
Yes.
For those of you who are unfamiliar, OpenACC, it's a parallel programming model targeting performance and portability. By that we want performance portability across a wide range of computer architectures. Here we show a short example of OpenACC directive in a prototype C++ application.
So as we can see on the left-hand side of the slide, we see the number of platforms OpenACC can target. So starting with Power and Sunway, x86 CPU, x86 Xeon Phi, along with, of course, NVIDIA GPU and the PEZI SC. Do you want to talk about the Cloverleaf?
So the performance numbers we're showing here are using the PGI compiler with the Cloverleaf hydrodynamics mini application that came from the Atomic Weapons Establishment. And so here we took the version of the Cloverleaf application downloaded from their website, and we compiled it, their version written in OpenMP and their version written in OpenACC, and we're comparing, in this case, the PGI compiled OpenACC version against the Intel compiled OpenMP version, both on a Haswell and on a Broadwell, and against the IBM compiled OpenMP version on IBM Power 8. So in each of these cases it was a dual socket system, and we're comparing against this performance on a single core Haswell. And we're showing is no penalty when you use OpenACC targeting a multi-core. You take the same OpenACC code and recompile it for a Tesla GPU, and you get this great performance boost. And all the way on the right is the performance with the brand new Volta GPU. Those two GPU lines were done on a Power 8 with the NVLink between host and GPU. Now, one of the things we're really touting here at ISC 17 is the number of applications that are being ported to GPUs using OpenACC. What we see on the top is 3 of the top 10 ISV HPC applications, as rated by Intersect 360, are now being ported, and in some cases have been released for GPU acceleration using OpenACC. 5 of the 13 Oak Ridge car codes being ported to GPUs or accelerated, preparing for Summit, are using OpenACC, and 5 of the main codes being used on the CSCS PIZ-DAINT supercomputer, also using OpenACC. There's a great validation of OpenACC as a programming model for GPU acceleration.
So this slide is on, so we are calling this year to be OpenACC for users, so it's a user year. So as the title of the slide indicates, it's a user-driven standard. And echoing Michael's previous slide that talks about the number of HPC applications that has been adopting OpenACC, we look at, I'm starting off with what's on the first bullet, which talks about 86% download. So what does that mean, right? So this is about the PGI Community Edition compiler. So ever since the compiler was released last SC, Supercomputing 2016 November, so that's the, that number shows the amount of downloads that has happened since then. And this is fabulous because, especially for teaching purposes, where I just ask my students in the classroom to simply download the compiler and just use it on their laptops, right? So it's that fair and simple. And lately, the compiler also targets a Windows platform, which makes it even more simpler. So people with Windows laptop can download and just use a compiler without worrying about license and payment and money and everything like that. And we have also been running OpenACC user group meetings. And the first one was at the Supercomputing Conference last year. We had a second one at GTC, and we had a third one just yesterday at ISC. And this is about growing the user community of OpenACC. And we also started a Slack communication channel. And it's exciting to see about 165 members over the period of 6 months, ever since we started the Slack channel last November, December. And the best part is the users that are posing questions on the Slack channel are non-computer scientists, which is great. We have people from mathematical sciences, we have people from physics, chemistry, who want to run OpenACC on their codes, and they have been using other programming languages and models for GPUs, and they're finding OpenACC very easy to adopt because you don't need to change the code as much as you would need to with respect to other alternate approaches that you may have. To follow up with that, we have been running many number of hackathons now. Since 2014, we have run like over average of 5 hackathons every year. And we have codes ranging from different domains, different sciences that have been submitting their applications to these hackathons. And that is also another signal, or another way to say that how the standard is really user-driven, because these hackathons gives a lot of feedback to the committee. They decipher compiler bugs, and this is just a few of several other benefits that come out of these hackathons.
So it's a user-driven specification, and we're coming up to a new version of the specification, which we'll talk about shortly. But the one most requested feature that we've had users ask for is this deep copy feature. So when we think about supercomputing, mostly we're thinking about arrays, matrices, and vectors. That's so last millennium. Applications we're seeing today have these incredibly complex structures. You have this array of structs or array of Fortran-derived types, but each element there, each struct has a pointer to another array that has some other properties about that field. And this other structure may be an array of struct, which has members that point to other structs. And we've seen applications where this levels of pointers go 4 deep. And now I want to do processing on that on the GPU. So I need to move the whole structure, the whole data structure, including all these dynamically allocated pointer-based structures, over to the device. And how do you do that in a way that's effective and efficient, fast and easy to use? So fast is important. It's not as important as easy to use, because you're not going to do this very often. So that's the deep copy problem. And we've been struggling with this now for more than 3 years. And it's not the most important feature globally, but it's the most requested feature. And what we decided is we need a way to do this in a way that provides the features that users need and the performance that's satisfactory, and gives the user the control they want without being so hard to use they can't figure out how to use it. So we've been struggling with this in the specification committee, in the OpenACC technical committee. And what we're doing now in PGI, changing hats, is a prototype implementation to make sure we can implement what we think we want to specify. And then based on that implementation, we'll work on the specification part and adding it to a future version.
So to follow up what Michael was saying, one of the requested features, right? So similarly to the hackathons right here, like I was following up with the previous slide, so you can look at the number of domains applications are coming from, and it ranges from astrophysics, weather, ocean modeling, molecular dynamics, next generation sequencing, cancer research, and so on and so forth. And it's a beautiful setting for several teams to come over, with mentors sitting next to the teams, and helping the teams come on board and migrate their codes to the GPUs. And some teams come with no GPU background, and by the end of 5 days, they are happy to see that their code is running on GPUs, and which may not really happen so quickly if not for the hackathon setting. So we have 3 more hackathons coming up for the rest of the year. There is one in NASA, there is one in CSCS. Application for Oak Ridge is still open, and that one is from 16 to 20 October 2017. And we had one at ULIC, one at Brookhaven National Lab so far in the year 2017. Did I miss another hackathon?
With respect to hackathons, if you want to move your code and get help to move your code to a GPU. These are not OpenACC hackathons, they're GPU hackathons. You can use OpenACC, you can use CUDA, you can use libraries, you can use OpenCL, you can use Python. What you get is free assistance from experts, free access to a high-performance accelerated supercomputer. You even get free food. It's a lot of fun, and it's a high-energy environment, and you will learn a lot, not just about GPUs, but about performance and your application. So another thing we're announcing is 3 new OpenACC members, HZDR, Shanghai Jiao Tong University, and Virginia Tech University. We're also announcing 2 new officers in the OpenACC organization. We have a new secretary, Guido Eukeland, who's from the HZDR organization. He's also the vice chair of SpecHPG. And Sunita Chandrasekaran, my partner here, is taking the position Director of User Adoption inside OpenACC to help promote the specification and to help users port their codes and adopt the specification. And for instance, she leads the user group. I already mentioned earlier, we're looking at a new version of the OpenACC specification. It's a relatively minor addition. These are a few fixes, some cleanup material, a few new features, nothing major, nothing as significant as deep copy. Our cadence is going to increase. We're going to have this specification ready for public review in just a couple of months, and we expect to do a new minor version within the next year and another new minor version within another year after that. Hopefully by then we'll be ready with something significant for the next major release.
So if I may add to it, OpenACC is a user-driven standard. So when these specifications, public specifications are out there, we would really welcome feedback. We need to know what you would like or how you would like the crafted features. So feedback most welcome. There are ways to write to us, so please do. All right. And this is a set of upcoming events, and we did have the user group meeting yesterday. There will be a workshop on performance portability, accelerators, heterogeneous computing, etc. tomorrow, June 22nd, Thursday at the Marriott. We have 3 upcoming hackathons at NASA, CSCS, and Oak Ridge. And Guido and I are running the WACPAD workshop, which is the 4th workshop on accelerators using directives for programming. And this is co-located with Supercomputing Conference. And this is on the November 13th, and call for papers is already out. And the submission deadline is August 22nd. So looking forward to your submissions.
From the show floor here at ISC 17 in the PGI booth, Michael Wolfe and Professor Sunita Chandrasekaran. Hope you come to this next year. We hope to see you there.